All matter is composed of one or more of the 100-odd elements. Of these, the atoms of the metals uranium and plutonium can be most readily fissioned to cause nuclear explosion. These elements are mildly radioactive.
Just as in other kinds of industry, the nuclear industry produces its share of waste. Since the beginning of the atomic age, thousands of tons of radioactive material have become a residual byproduct of nuclear weapons and nuclear energy manufacture. Mostly, this byproduct consisted of a form of uranium, technically called uranium-238. Soon, nuclear scientists, with close military assessment, proposed a number of futuristic names for this waste, until they finally chose the one that sounded the least harmful. They called it depleted uranium, or DU, probably because it was no longer useful to make this. But something that falls short of destroying the world is not necessarily healthy. Depleted uranium is not decaffeinated coffee. For decades, it was handled as a nuclear waste that had to be stored in high-security facilities. Sadly, such cares did not last very long. Despite the fact that depleted uranium's radioactive properties have a lifespan of 4.5 billion years, which is roughly the age of our young planet Earth, in a blink of an eye, the U.S. Nuclear Regulatory Commission assigned DU the new tag of resource material. And even if the new name did not change any laws of physics, it certainly changed the rules of engagement in modern warfare. Since the first Gulf War, this new resource material has been used as a main component in conventional armor-piercing munitions. And not only was this a cheaper alternative for safe nuclear waste disposal, for many others around the world, this meant that there was a price to pay.
One of our medics came in and told us that the Dutch Marines had come in to relieve us and that we were going to push further north into Iraq and they were going to take up this position. The Dutch Marines is a unique organization because they have a union, and this union came in and they had Geiger counters and they surveyed the area in Al Samawat where we were living, and they found it to be radioactive and told us that it was uninhabitable, and why were we there?
It seems that no great military power considers important to inform its own soldiers where it has used depleted uranium weapons. And yet, a few days after the United States Army completed its invasion of Afghanistan in 2001, the Department of Defense announced the finding of DU fragments in underground caves. The American officers asserted that the Taliban were intending to use it as part of what is known as a dirty bomb, a device that employs conventional explosives as a way to scatter attached radioactive material. But ironically, there was likely more depleted uranium in Afghanistan outside the Taliban caves. The Pentagon may have scattered throughout this country much more DU as part of conventional munitions. Moreover, more than 300 tons were fired by the U.S. Army in Iraq, Kuwait, and parts of Saudi Arabia during the first Gulf War in 1991. Then, a few years later, the Balkan War theater received another 14 tons in bombings, and then again, Iraq took a hit of another 140 tons in 2003. Not to mention an undetermined quantity that the Pentagon has used in testing sites inside the United States, Puerto Rico, and in the island of Okinawa in southern Japan. And yet, this is a small percentage of the more than 1 million tons of DU in existence. If you are now intrigued as to why the rich countries of the world seem to be using dirty bomb material, maybe we should start by explaining in the first place what depleted uranium is. Uranium is a heavy metal that is found naturally in the Earth in 3 different forms called isotopes. Every isotope of a material contains atoms with the same number of protons in their nuclei, but they differ from each other in that they have a distinct number of neutrons. Every uranium isotope has 92 protons, but if it had 146 neutrons, then it would be uranium-238. Along with uranium-238, the isotopes 235 and 234, this latter in very small amounts, make up the 3 natural forms of uranium. All of them are found mixed in uranium-rich minerals, but can be separated artificially. Depleted uranium, then, is no other than the isotope uranium-238 in an almost pure form, split from uranium containing important percentages of uranium-235, which is called, in contrast, enriched uranium. This enriched uranium is the one with the capability of sustaining chain reactions, which make nuclear bombs and reactors work. Yet, the distribution and nature of these isotopes is very uneven. For every kilogram of enriched uranium obtained, 7 kilograms of DU result as nuclear waste. Although nearly 20 countries are known to use DU in their arsenals, no other military institution has gotten so much out of this waste than the US Army. The Pentagon obtains from it a substantial part of its tank and air artillery munitions, and DU presence is suspected in some of its long-range missiles. Depleted uranium itself is not used as an explosive, but as a penetrating material. With nearly twice the density of lead, projectiles fabricated with this metal easily pierce all kinds of armor. For instance, in the case of an Abrams tank ammunition, the casing's main body contains an explosive combustible that propels a slim DU projectile placed in the forefront of the shell. When fired, it loses an aluminum frame that keeps it aligned along the cannon, and the remaining projectile is a DU dart no thicker than a broomstick. The sheer heat produced by the impact disintegrates something between 30 to 70% of the projectile's mass before it exits the other side of the target, leaving a deadly wake of incandescent metal that burns alive the vehicle's crew. Yet, the controversy over these weapons comes not from the way they kill on the battlefield, but rather from the clouds of radioactive and chemically toxic dust ejected to the atmosphere by the disintegrating ammunition at impact. Anyhow, the Pentagon has already created what may be called a DU diplomacy, insisting to the public that there are 3 main reasons as to why spreading DU dust represents no danger. First of all, the Pentagon says that depleted uranium is considerably less radioactive than natural uranium. The reason is that the 238 isotope emits mainly a weak kind of radiation that does not penetrate the skin, known as alpha radiation. Secondly, the Pentagon argues that the fallout of DU particles only cover a 50-meter perimeter around the impact point and does not reach populated areas. And thirdly, the Pentagon asserts that there is no health crisis among soldiers or civilians whose symptoms may be linked with DU exposure.